Good evening, students. I hope it is audible clearly. I'll start with the class. They are brought into contact and they kept at the same distance. The ratio of the magnitudes of electrostatic forces between them before and after contact is. Yes. So the options are 24:1, 4:1, 12:1, and 8:1. See, ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು ಇಲ್ಲಿ, that is you have the two metal spheres of charge. Actually question ಅಲ್ಲಿ 12 microfarad ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. It is charge ಅಂದ್ರೆ it should be coulomb. Okay, so it should be coulomb there. Next, one body is having a charge plus 12 microcoulomb and the second body is having a charge minus 8 microcoulomb. They're kept at certain distance in the air. They are brought into contact and then kept at the same distance. So you can draw according to what they are telling. So I have the two spheres. It's the second sphere. This is having charge plus 12 microcoulomb and this is having a charge minus 8 microcoulomb. Okay, so initially these are at some distance. Later they will bring both the charges in contact with each other. Again they will keep the charges at the same distance. Yes. So here what happens to the force between them? So initially when the bodies are in contact, according to Coulomb's law, what is the force acting on the body? That is F1 is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. Then next, Substitute the values here. That is 1 upon 4 pi epsilon naught. What is Q1? What is Q2? Q1 is 12 into 10 raised to minus 6. Then what is Q2? That is minus 8. So when it is force we are calculating, no need of taking the minus sign here. That is 8 into 10 raised to minus 6. But potential ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಕೆಲ್ ತಗೋಬೇಕಾಗತ್ತೆ minus ಅನ್ನ divided by r square. Okay, this is my equation 1. Next, I'll write F2 is equal to. So F2 ಏನಾಗತ್ತೆ ಇಲ್ಲಿ, you are bringing the charges in contact. ಮತ್ತೆ ಅದನ್ನ ಸೇಮ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಡ್ತಾ ಇದ್ದೀರಾ. So when you are bringing the charges in contact, here the exchange of the charge takes place. Therefore, plus 12 minus 8, it will be plus 4. So plus 12 plus minus 8, it will be plus 4. So this body will get the charge of 2 microcoulomb and this body will also get the charge of 2 microcoulomb. I hope you understood this. That is, we have the two bodies. That is, one is of the charge plus 12 microcoulomb and the other is of the charge minus 8 microcoulomb. With respect to that, the coulomb force is given by F1 is equal to 1 upon 4 pi epsilon naught 12 into 10 raised to minus 6 into 8 into 10 raised to minus 6 divided by r square, equation 1. Second step, when you bring the charges in contact with each other and when you separate them, the exchange of the charges will take place. That is plus 12 minus 8, it becomes plus 4. So 2 microcoulomb one body baratte, matte 2 microcoulomb mattond body baratte. Now the force is becoming, that is 1 upon 4 pi epsilon naught. It is 2 into 10 raised to minus 6 into 2 into 10 raised to minus 6 divided by r square. This is my equation 2. So now I require the ratio of the forces. So what I'll do, I'll divide it F1 divided by F2. So if I take F1 divided by F2, ಇಲ್ಲಿ ನೋಡಿ F1 ಏನಿದೆ 1 upon 4 pi epsilon naught 12 into 10 raised to minus 6 into 8 into 10 raised to minus 6 divided by r square. Okay, this whole, then this entire divided by 1 upon 4 pi epsilon naught 2 into 10 raised to minus 6 into 2 into 10 raised to minus 6. Next ಇದು divided by ಏನಾಗುತ್ತೆ r square ಅಂತ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ students, this 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught will get cancelled. R square will also get cancelled. So what we are left with, 12 into 8. So 12 into 8 is, it is 96 divided by 2 into 2, it is 4. 10 raised to minus 6, 10 raised to minus 6 kuda cancel agutte. So now if you simplify, this is 4 ones are Yes, students, solution is clear. Option. I'll go for the next question. I hope it's clear to everyone. So please interact, speak, and only you will know you are understanding more, students. Go for the next question. Yes. So the next question is, a small conducting sphere of radius r is lying inside a bigger hollow conducting sphere of radius. Option A. Previous question answer is option A. Answer A. Should I repeat it once again? Okay, ನಾನು ಮತ್ತೊಂದ್ಸಲ ರಿಪೀಟ್ ಮಾಡ್ತೀನಿ ನೋಡಿ ಇಲ್ಲಿ. It is you have two bodies. Yes. So you have two bodies. First one is having charge plus 12 microcoulomb, and the second body is also having the charge minus 8 microcoulomb. They are separated by some distance. Next thing, you are getting these bodies close to each other. Audible or you people also sit in the network place, otherwise you will not able to hear me properly. Yes, next in you are getting both the charges close to each other. So now when you bring the charges close to each other, one is having 12 microcoulomb and the other one is having 8 microcoulomb. It plus 12 ide, it minus 8 ide. So ಏನಾಗತ್ತೆ, the net charge will be 4 microcoulomb. One would acquire 2 microcoulomb, other body will acquire 2 microcoulomb. Okay, so ಅವ್ರು ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ನಿಮ್ಗೆ, the ratio of the forces F1 divided by F2, ratio of the forces are asked. I hope it is clear now. Now F1 is equal to, so F1 is equal to, according to Coulomb's law, it is 1/4 pi epsilon naught Q1 into Q2 divided by R square. So which is equal to 1/4 pi epsilon naught Q1 Q2 value. What is Q1 Q2 value? It is 12 into 10 raised to minus 6 into Q2 ಎಷ್ಟಿದೆ ಮೈಕ್ರೋ ಅಂದ್ರೆ 10 raised to minus 6 ಆಗುತ್ತೆ ಹೌದಲ್ಲ. It is minus ಏನ್ ಬೇಕಾಗಿಲ್ಲ, because force calculate ಮಾಡ್ಬೇಕಾದ್ರೆ minus ನಾವು ತಗೊಳ್ಳಲ್ಲ. 8 into 10 raised to minus 6, this whole divided by R square. This is my equation 1. F1 ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. I'll go for F2. F2 is equal to 1/4 pi epsilon naught Q1 into Q2 upon R square. So substitute ಮಾಡ್ಕೊಳ್ಳೋಣ. 1/4 pi epsilon naught, keep it as it is. Q1 Q2 ನಾನು ನಿಮಗೆ ಅಷ್ಟೇ ಹೇಳಿದೆ. So when you closer and take it lightly, 2 microcoulomb ಅಂದ್ರೆ 2 microcoulomb ಅಂತ ಆಗುತ್ತೆ body charge. So now Q1 Q2 value is what? 2 into 10 raised to minus 6 into 2 into 10 raised to minus 6. This whole divided by it is R square. Now you have equation 1 and you have the equation 2. So divide equation 1 divided by equation 2. Yakandre avaru the ratio of the magnitude of the force they are asking before and after the contact. So before and after the contact ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So before contact force ಏನಿತ್ತು F1 ಅಂತ ಇರುತ್ತೆ. After contact ಏನಾಗುತ್ತೆ, force F2 ಅಂತ ಆಗುತ್ತೆ. So therefore it is 1/4 pi epsilon naught 12 into 10 raised to minus 6 into 8 into 10 raised to minus 6. This whole divided by R square. F1 ಆಯ್ತು. ಕಡೆಗೆ F1 F2 ಏನಿದೆ 1/4 pi epsilon naught 2 into 10 raised to minus 6 into 2 into 10 raised to minus 6. this whole divided by the r square anta agutte 1/4 pi epsilon naught 1/4 naught r square. Next, so 10 raised to minus 6 kuda cancel agutte numerator denominator. Now 12 into, so 12 into st the students it is 96 divided by 2 into 2 it is 4. So 1s are 4 2s are 4 4s are, so therefore it is 24 divided by 1. So 24 is to 1 the answer. Now is it clear? 24 is the, let know you understood. Okay. When you are calculating minus now in consider ಮಾಡಲ್ಲ ಚಾರ್ಜ್ ಮೈನಸ್ ಏನ್ ಬರುತ್ತೆ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಲ್ಲ ಬಟ್ ಪೊಟೆನ್ಶಿಯಲ್ ನೀವು ಯಾವಾಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇರ್ತೀರಾ that time plus minus matters, but for force calculation for that signs we don't consider. So I hope you have copied down also. I'll go for the next question. So just take the ratio of the forces. Aste. So the second question is, a small conducting sphere of radius r is lying concentrically of radius r. Okay, first ಏನ್ ಕೊಡ್ತಾ ಇದ್ದಾರೆ ಅದರ ಪ್ರಕಾರ ನಾವು ಡಯಾಗ್ರಾಮ್ ಹಾಕ್ತಾ ಹೋಗೋಣ. ಸೊ ನಿಮ್ಮ ಹತ್ರ ಎರಡು ಸ್ಪಿಯರ್ ಇದೆ, ಒಂದು ಸ್ಮಾಲ್ ಸ್ಪಿಯರ್ ಮತ್ತೊಂದು ದೊಡ್ಡ ಸ್ಪಿಯರ್ ಇದೆ, ಅದ್ರ ಒಳಗಡೆ ಅದಿದೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ದ ಬಿಗರ್ ಸ್ಪಿಯರ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ರೇಡಿಯಸ್ ಕ್ಯಾಪಿಟಲ್ ಆರ್, ದ ಸ್ಮಾಲರ್ ಸ್ಪಿಯರ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ರೇಡಿಯಸ್ ಸ್ಮಾಲ್ ಆರ್. The bigger and the smaller spheres are charged with, so bigger sphere capital Q anta kottidare, small sphere du charge small q anta helidare. And they are also saying that your Q is greater than your small q and are insulated from each other. So insulated from each other andre charge enal exchange ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ಅರ್ಥ. The potential difference spheres will be potential difference ಅವರು ಕೇಳ್ತಾ ಇದ್ದಾರೆ v1 minus v2 ಅಥವಾ v2 minus v1. Question is clear? That is, you have two small conducting spheres. One is of the radius smaller and a bigger sphere whose radius is capital R. So both are having the charge, a bigger and the smaller sphere, capital Q and the small q. Okay, the potential difference between these. So let us see what is the solution for that. So first, for the bigger sphere, let us write the potential VA. This is for bigger sphere. 1/4 pi epsilon naught. Charge enide Q anta ide. Then what is the radius? It is R. So it is 1/4 pi epsilon Q by R. Next, VB is equal to, it is 1/4 pi epsilon naught. Next, idén charge ide, small q ide, radius is what it is? Small r. Okay. Yes, so this is for A body and this is for B body. But see here, the A body nimgenide bigger sphere. Bigger sphere ige ಏನಾಗುತ್ತೆ, bigger sphere is influenced by the smaller sphere. ನಾನು ನಿಮ್ಗೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳಿದ್ದೆ, ಇಲ್ಲಿ ನೋಡಿ, you have this point P surrounded by the charge Q1, Q2, Q3. Yes, so whatever your point P is there, this is having the potential due to Q1 also. This is having the potential due to Q2 also. This point P is having the potential due to Q3 also. Howda? Same illenagatte. Same way, your bigger sphere, capital R, and this is small r, will have the potential due to this small q also. So small q ಎದ್ರದಂತ ಹೇಳ್ತಿದ್ದೀವಿ, small q is the charge of the radius r and capital Q is the charge of the capital R. So ನಿಮ್ದು bigger sphere ಮೇಲೆ smaller sphere ದಿಂದ ಕೂಡ potential act ಆಗುತ್ತೆ. So first equation I am writing, due to the charge capital Q, it is VA is equal to 1 upon 4 pi epsilon naught capital Q divided by capital R. Next, VA is also is equal to 1 upon 4 pi epsilon naught small q divided by capital R. ಇದು ಯಾರಿಗೆ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ನೀವು ಕೇಳಿ, ಇಲ್ಲೇನೆ ಕೇಳಿ. ನಾನು ನಿಮ್ಗೆ ಏನಂತ ಹೇಳ್ತಿದ್ದೀನಿ, ಯುವರ್ ಬಾಡಿ ಔಟರ್ ಬಿಗ್ಗರ್ ಸ್ಪಿಯರ್ ಏನಿದೆ, ದ ಪೊಟೆನ್ಶಿಯಲ್ ಫಾರ್ ದಿಸ್ ಬಿಗ್ಗರ್ ಸ್ಪಿಯರ್ ಈಸ್ ಡ್ಯೂ ಟು ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಆಲ್ಸೋ. ಫಾರ್ ದ ಬಿಗ್ಗರ್ ಸ್ಪಿಯರ್ ದ ಪೊಟೆನ್ಶಿಯಲ್ ಈಸ್ ಡ್ಯೂ ಟು ದ ಸ್ಮಾಲ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಆಲ್ಸೋ. ಯಾಕಂದ್ರೆ ಇದು ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸರ್ಕಲ್ ಅಥವಾ ಕಾನ್ಸೆಂಟ್ರಿಕ್ ಸ್ಪಿಯರ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. I hope this is clear. The potential for the bigger sphere is due to capital Q charge and to the small q. Now, let us write for the inner sphere of the radius small r. So for that, the potential of this B means a smaller sphere is given by 1 upon 4 pi epsilon naught Q divided by R, due to the same charge, due to the same radius. Then VB is also given by 1 upon 4 pi epsilon naught divided by capital R, because this is inside baratte. This is for the inside of the body. These two expressions for the inner sphere. This expression is for the outer sphere. So this expression is for the outer sphere. So ನಾನು ಇಲ್ಲಿ ಯಾಕೆ ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಮತ್ತೆ ಕ್ಯಾಪಿಟಲ್ ಆರ್ ತಗೊಂತಾ ಇದ್ದೀನಿ ಅಂತಂದ್ರೆ, ಇನ್ನರ್ ಸ್ಪಿಯರ್ ಗೆ ಹೊರಗಡೆಯಿಂದ ನೀವೇನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ ಅವಾಗ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಪಿಟಲ್ ಆರ್ ಅಂತ ತಗೋಬೇಕಾಗತ್ತೆ, ಡ್ಯೂ ಟು ದ ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಚಾರ್ಜ್. ಈ 4 equations ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದೆಯಾ? Later only subtraction we need to do. So first ಇಲ್ಲಿ ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. All 4 equations is clear to everyone? As given is circle or the concentric sphere, the potential is for the each body with respect to both the bodies we will take. ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಹೇಳಿ, ಈಗಲೇ ರಿಪೀಟ್ ಮಾಡ್ತೀನಿ. Already 2 times I have repeated. The potential due to bigger sphere is given by capital Q also and small q also. ಅಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಏನ್ ಚೇಂಜ್ ಆಗಲ್ಲ, ಕ್ಯಾಪಿಟಲ್ ಆರ್ ಮತ್ತೆ ಆರ್ ಬರುತ್ತೆ. ಬಟ್ ವೆನ್ ಯು ಆರ್ ಟೇಕಿಂಗ್ ಇನ್ನರ್ ಸ್ಪಿಯರ್, ಒನ್ ಇಸ್ ಡ್ಯೂ ಟು ಸ್ಮಾಲ್ ಚಾರ್ಜ್ and the distance is smaller. Then the next is capital Q. As per considering the outer sphere, it will be capital R distance. So now take the difference of the values. Then that is the answer. So let's do numericals. It will be and especially this lesson, it is little complicated. So now the potential at A is given by it is VA is equal to 1 upon 4 pi epsilon naught inside the bracket 2 by R Q by R. The potential due to B is given by it is 1 upon 4 pi epsilon naught. It is Q by R plus Q by R. And the potential difference for VB minus is equal VA is equal to 1 upon 4 pi epsilon naught Q by R plus Q by R. With respect to B, it is 1 upon 4 pi epsilon naught Q by R plus Q by R. We require the potential difference, therefore VB minus VA is equal to 1 upon 4 pi epsilon naught inside the bracket. So VB is Q by R plus Q by R minus Q by R plus into minus Q by capital R. So can same terms ಯಾವ್ದಿದೆ ನೋಡಿ, capital Q by R plus minus cancel ಆಗುತ್ತೆ. So you are left with 1 upon 4 pi epsilon naught inside the bracket small q by R minus small q by capital R. So which option is right? ಯಾವ್ದು ಆಪ್ಷನ್ ಕರೆಕ್ಟ್ ಇದೆ ನೋಡಿ. So it is option C. Yes. C, it will be C. Capital Q by R will get cancelled. So option C is correct. Other students? Okay, so I'll go for the next question. This one theory question we will take. Then we will take the numerical. Yes, see this question. There is a uniform electric field of intensity capital E, which is as shown in the figure. So you have the electric field intensity capital E, which is shown in the figure. Okay. How many labeled points have the same electric potential as the fully shaded point? So question meaning ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, ಅವ್ರು ನಿಮ್ಗೆ ಇಲ್ಲೊಂದು ಫಿಗರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. In the figure they are giving you the electric field intensity as capital E. ಆಯ್ತಾ? So ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು ಸೆಕೆಂಡ್ ಲೈನ್ ಅಲ್ಲಿ, in the second line here the one is shaded. You can see one point is shaded here at this point. So here it is shaded. ಹೌದಾ? ಅವ್ರು ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, how many labeled points have the same electric potential as the fully shaded point. So ಈ ತರ shaded ಏರಿಯಾದು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದ್ರದ್ದು ಪೊಟೆನ್ಶಿಯಲ್ 2 ವೋಲ್ಟ್ ಅಂತ ಇದ್ದಾಗ ಮತ್ತೆ ಎಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ಪೊಟೆನ್ಶಿಯಲ್ 2 ವೋಲ್ಟ್ ಇರುತ್ತೆ ಅಂತ ಕ್ವಶನ್ ಅರ್ಥ ಆಯ್ತಾ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದ ಶೇಡೆಡ್ ಏರಿಯಾ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಪೊಟೆನ್ಶಿಯಲ್ 2 ವೋಲ್ಟ್. How many surfaces or how many points are having the same potential? How many surfaces are having the same potential? The options are 2, 3, 8 and 11. So here, according to the properties of the equipotential surface, so equipotential surface alli the normal, along the normal the points are having the same potential. Okay, so if you consider electric field lines e directional ide, electric field lines ke perpendicular line. Okay, that is nothing but the normal to the electric field lines. These are having the electric potential same value. So same value ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದ್ರೆ ಇದ್ರ ಅರ್ಥ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇದ್ರಲ್ಲಿ ಯಾವ್ದು equipotential surface ಇದೆ ಅಂತ. So equipotential surface properties ಪ್ರಕಾರ here electric field ಗೆ normal to the surfaces are always having the same potential value. So same potential ಇರೋದು ಎಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ಆಗುತ್ತೆ ನೋಡಿ, 1, this is 2 and this is 3. So 1, 2, 3. So shaded ಇಲ್ಲಿ ಬರುತ್ತೆ. Okay, so shaded will be here. ಇದನ್ ಬಿಟ್ಟು ಇಲ್ಲೊಂದಿದೆ, ಇಲ್ಲೊಂದಿದೆ, ಇಲ್ಲೊಂದಿದೆ. So 1, 2, 3. So total 3 points are having the same potential. I hope you are convinced with the answer. Yes, everyone. So option B, because the electric field along the normal or along the perpendicular surfaces, the potential value will be equal. Therefore, option C, B is the correct option. That is 3. Yes. Next question. Yes. The electric potential at any point XYZ in meter is given by V is equal to 3x square. The electric field at a point 2 meter, comma 0 and 1 meter is. Yes. So what they're asking you, they're asking you the electric potential at any point in meter when the electric field is given for 2 meters, comma 0 and comma 1 meter is. So how to do this? That is, see, the electric field ಮತ್ತೆ potential relation ನೆನಪಿದ್ಯಾ? The electric field is nothing but it is dv by dx. So v ಅಂದ್ರೆ potential ಆಗತ್ತೆ, e ಅಂದ್ರೆ electric field ಆಗತ್ತೆ. The relation between the electric field and the potential is given by E is equal to minus dv by dx. So it is equal to minus dou by dou x or the d by dx. V value ಎಷ್ಟಿದೆ ನೋಡಿ question ಅಲ್ಲಿ, it is 3x square. It is 3x square. So this is equal to differentiation ಕಲ್ತಿದ್ದೀರಾ? In maths you people have learned differentiation. What is x to the power n differentiation?
Nx to the power x minus n. N
Yes.
minus 1.
So that is in differentiation of x raised to n is given by n into x raised to n minus 1. So ನೀವು integration ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, x raised to n plus 1 divided by n plus 1 ಅಂತ ಆಗುತ್ತೆ. Therefore ಇಲ್ಲಿ ನೋಡಿ, so according to differentiation formula n place ಅಲ್ಲಿ ನಮಗೆ 2 ಇದೆ. So ಇಲ್ಲಿ already 3 ಇದೆ. 3 into 2 it will be 6x. It will be 6x. As we have the minus sign, so the minus sign will continue here. So here it is minus. Okay. So electric field ನಮ್ದು ಎಷ್ಟು ಅಂತ ಬಂದಿದೆ ಈಗ, minus 6x ಅಂತ ಬಂದಿದೆ. ಅವ್ರು ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಕೊಡ್ತಿದ್ದಾರೆ, the electric field at a point 2, 0 and 1 they are giving already. ಹೌದಾ? So 2, 0, 1, 2 values, 2 ಇಲ್ಲಿ substitute ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? It will be minus 12 volt per meter. It is minus 12 volt per meter. Therefore, the answer is, it is option D. It is option D. Okay. So in the option, they are giving only one, we can put x as 1. Here actually they have given 3 points. In the options actually there should be 3 answers. That is, one should be minus 12 and one should be 0 and the other should be, it is minus into will be minus 6. So here actually 3 options they have to give, but they have given minus 12 and minus 6 both they have given. So actually we can consider B and D both the answers here. B ಮತ್ತೆ D ಎರಡು consider ಮಾಡಬಹುದು ನಾವಿಲ್ಲಿ. ಇಲ್ಲ ಅಂದ್ರೆ options ಅಲ್ಲಿನೇ ಎಲ್ಲ 3 points ಕೊಟ್ಟಿದ್ರೆ it would be good. So we can choose B and D. We can substitute one also here. So B and D. Yes. I hope the solution is true. I'll go for the next question. Yes. See. Okay. See here. In this diagram, the difference A and B is 60 volt. Potential difference 60 volt. The potential difference across 6 microfarad capacitor is. So the potential difference across A and B. You will A ಮತ್ತೆ B point and ನೋಡ್ತಾ ಇದ್ದೀರಾ. The potential difference is how much? It is 60 volt. The potential difference across 6 microfarad capacitor is. So ನಾವಿಲ್ಲಿ directly 6 ದಷ್ಟೇ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ಯಾಕೆ ಹೇಳಿ? ಇಲ್ಲಿ ಏನಾಗಿದೆ between A and B point here we have ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಇದೆ, then next ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಇಲ್ಲೊಂದಿದೆ. ಹೌದಾ? So directly we cannot calculate the potential of the 6 microfarad. So what we need to simplify this equation. Still ನೀವು ನೋಡಿದಾಗ 6 ಮತ್ತೆ 3 it is connected in mode, that is it is connected in the series. ಹೌದಾ? These two are getting ಮತ್ತೆ ಇದು 3 ಮತ್ತೆ 3 ಇಲ್ಲಿ ಕೆಪಾಸಿಟರ್ ನೋಡಿದ್ರೆ these two are connected in parallel. Next 3 microfarad it is in series. ಹೌದಾ? So two capacitors are in series, that is 6 and 3. Other than 2 are in parallel, that is 3 ಮತ್ತೆ 3 ಅಂತ. ನೆಕ್ಸ್ಟ್ ಇದೆಲ್ಲ ಸಿಸ್ಟಮ್ ಇಲ್ಲೊಂದು ಕೆಪಾಸಿಟರ್ ಕನೆಕ್ಟ್ ಇದೆ ಅಂಡ್ ಇದ್ರದ್ದು ಕೆಪಾಸಿಟರ್ ಎಷ್ಟಿದೆ? 3 microfarad. Yes. So now what is the question? 6 microfarad ಅಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಇದೆ ಅಂತ equation first effective capacitance calculate ಮಾಡೋಣ. So effective capacitance calculate ಮಾಡಬೇಕಾದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ parallel. I hope you remember the formula. If the capacitors are connected in parallel, the formula is C1 plus C. If capacitors are connected in series, 1 upon CS is equal to 1 upon C1 plus 1 upon C2. I hope you remember this. ಹೌದಾ? ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ ನಮ್ಮ ಹತ್ರ? 2 ಮಾತ್ರ ಇದೆ, that is nothing but 3 3. So 3 plus 3 ಆಗುತ್ತೆ 6 ಅಂತ ಆಗುತ್ತೆ. 6 microfarad. Now so E6 microfarad it is in series connection with the remaining 3. So ಈಗೇನಾಯ್ತು? ಇದು 6 ಇದೆ, ಇದ್ರದ್ದು 3 ಇದೆ. ನೆಕ್ಸ್ಟ್ ಇದಿಲ್ಲೇನ್ ಪ್ಯಾರಲಲ್ ಇತ್ತಲ್ಲ, ಇದ್ರದ್ದು ನಾವು ಇಫೆಕ್ಟಿವ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಕೆಪಾಸಿಟನ್ಸ್ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀವಿ. ನಮ್ಗೆ ಎಷ್ಟು ಬಂದಿದೆ ಆನ್ಸರು? So E6 ಏನಿದೆ? It is in the parallel series connection now. Next last one, this is 3. So ಇದು 6 ಇದೆ, 6 plus 3 plus 6 plus 6, 3. I hope this much is clear to everyone. ಯಾರಿಗಾದ್ರೂ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಹೇಳಿ, otherwise you can tell me to repeat there itself. So I'll repeat. First 2 resistors are in series, next 2 resistors are in parallel, and the fifth resistor is in series. ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡು effective resistance effective capacitance ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀನಿ. I am getting here 6 for that. Now all the 4 capacitors are in series connection. So apply the series formula, that is 1 upon C is equal to 1 upon 6 plus 1 upon 3 plus 1 upon 6 plus 1 upon 3. So now if I take the LCM will be 6. So it will be 1 plus 2 plus 1 plus 2. So 2 plus 1 is 6. So it is 6 by 6, it is 1. So 1 by 6 is also equal to 1 microfarad. ಇದು ನಮ್ಗೆ ವ್ಯಾಲ್ಯೂ ಬಂತು. ಈಗ ಕೆಪಾಸಿಟನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಬಂತು. ಆಯ್ತಾ? Now the charge on this capacitance is given by C into V. Therefore C is how much? It is 1 microfarad into potential ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? 60 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. 60 into 60 itself. Charge is 60 microcoulomb. Charge is Q is equal to 60 microcoulomb. ನೀವು ಈಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು the potential value. So the potential value is given by, so the potential is equal to capacitance ಎಷ್ಟು ಅಂತ ಹೇಳಿದ್ರು ಅವರು 60 ಅಂತ ಹೇಳಿದ್ರು 60 microfarad. ನಮ್ದು ಚಾರ್ಜ್ ಎಷ್ಟು ಬಂದಿದೆ that is microfarad plus microcoulomb is the charge. What is that? Capacitance is equal to formula Q is equal to CV. So ನಮ್ಗೆ potential is the option A. I'll repeat. We have 5 capacitors, 2 are in parallel, 3 are in series. So parallel ಇದ್ದಿದ್ರನ್ನ ನಾವು ಇಲ್ಲಿ first we have calculated for the parallel, that is Cp is equal to 3 plus 3, that is 6. Next series calculate ಮಾಡಬೇಕಾದ್ರೆ the formula is 1 upon C is equal to series ಅಲ್ಲಿ first 6 microfarad ಇದೆ, next 3 microfarad ಇದೆ, next ಇದೆರಡು parallel ದು effective ಎಷ್ಟು ಬರುತ್ತೆ 6 ಬರುತ್ತೆ, so it is 1 by 6 plus 1 by 3. ಇದನ್ನ ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ here you are getting the capacitance value as 1 microfarad. It is 1 microfarad. So ಈ 1 microfarad ಇದ್ದು ನಾವು ಈಗ ಏನ್ ಮಾಡ್ತೀವಿ ಚಾರ್ಜ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So it is C into V. So C is how much? It is 1 microfarad into potential ಎಷ್ಟಿದೆ A ಮತ್ತೆ B ಮಧ್ಯದಲ್ಲಿ 60 ವೋಲ್ಟ್ ಅಂತ ಇದೆ. ಹೌದಾ 60 ವೋಲ್ಟ್ it is. So 60 into 1 how much it is? It is 60 microcoulomb. ಇದು ನಮ್ದು ಈಗ ಚಾರ್ಜ್ ಬಂತು. ಅವ್ರೇನ್ ಕೇಳಿದ್ದಾರೆ ಕ್ವಶನ್ ಅಲ್ಲಿ the potential across 6 microfarad capacitor. So we know potential is equal to Q divided by C. So Q ನಾವು ಈಗಷ್ಟೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ 60 microcoulomb ಮತ್ತೆ potential sorry capacitance ಕ್ವಶನ್ ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾರೆ 6 microfarad ಅಂತ. So micro will get cancelled. So 6 ones are 6 tens are, that is 10 volt is the answer. So 3-4 times I have revised it. ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ you can ask me. This based on circuits, little you need to apply logic. So ಯಾರಿಗೆ it is not necessary that everyone should understand. So this type of questions little you need to think. Yes, Anvita, Diksha, Jyoti, Manikanta, Netravati, Priyanka. ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ತಿಳಿದಿಲ್ಲ ನೀವು ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಮಾತಾಡಿ, ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Okay, I hope no problem. One simple question we will solve. Otherwise you will think that okay. So before you set totality, we will take one easy question. Yes. A capacitor of capacitance of farad is 10 volt. The energy stored in it is ಸೊ ಆಲ್ರೆಡಿ ನಿಮ್ಗೆ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಬಗ್ಗೆ ನಾವು ಡೆರಿವೇಶನ್ ಮಾಡಿದ್ವಿ ಕ್ಲಾಸ್ ಅಲ್ಲಿ. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಟ್ ನಾನು ಫಾರ್ಮುಲಾ ಕೊಡ್ತೀನಿ, ನೀವು ಸಿಂಪ್ಲಿ ಮಾಡಿ ಆನ್ಸರ್ ಹೇಳಿ. The energy stored in the capacitor is given by actually 3 formulas ಇದೆ. ಇಲ್ಲಿ capacitance value ಮತ್ತೆ voltage ಕೊಟ್ಟಿದ್ದಾರೆ or the potential. So I'll take the formula half CV square. I'll take half CV square. Let's see who all will get the answer. So very simple, 1 by 2 into capacitance into voltage square. Who got the answer? Priyanka is telling option B. Yes, it is option B. What about others? Yes, students. ಬೇರೆ ಎಲ್ಲರಿಗೂ ಆನ್ಸರ್ ಬಂತ? ಆಪ್ಷನ್ ಬಿ ಬರುತ್ತೆ. ವೆರಿ ಸಿಂಪಲ್ ಇಟ್ ಇಸ್. ವೆರಿ ಗುಡ್. Okay. So in the next class we can see the remaining questions. Again, two classes we will do on the capacitors, such type of numericals. Okay. So neatly ಸ್ವಲ್ಪ ಈ ತರನೇ ಬರುತ್ತೆ. You need to focus on the questions and the concepts. Yes. Okay, everyone. Thank you. Thank you for your time.